welcome to DEITV. I'm your host, Salomon Guajardo. Today's episode will cover the Kvalseth index. Before providing the overview and the application of the Kvalseth index, I'm going to review the different types of indices. Because the Kvalseth index is based on the Simpson index, I'll review the Simpson index. Again, as I stated, I'll cover the Kvalseth index and apply it to the same gender, ethnic, and revenue data that's been presented in the previous episodes. I will have a quick discussion on additional resources, and then I'll have a quick summary or introduction to episode 7. Thank you and stay tuned. As I mentioned in previous episodes, we have two types of indices. Those that are probability-based indices and logarithm-based indices. Under the probability-based indices, we have the Holbert index. Today's episode will cover the Kvalseth index. We have the McIntosh index that was covered in the previous episode. We have the Simpson index, which is the basis for additional diversity indices. We have the Smith-Wilson indices, which were covered in episode 2. We have the Wilcox index, which was covered in the previous episode. Under the logarithm-based indices, we have the Shannon index. Again, it's the basis for additional indices, such as the Heap index, the Hill index. We have the Holbert logarithm-based index. We have the Sheldon index, and also we have the Smith-Wilson logarithm-based indices. As I mentioned in episode 1, we have the Simpson index. Presented here on this side, we have the Bias-Simpson index. And the Bias-Simpson index is represented as 1 minus the sum of the frequency squared divided by the total number of individuals squared. Again, as in previous episodes, that's SD equals 1 minus the sum of small n squared divided by big N squared. That also can be written as 1 minus the sum of the percentages squared. That also can be written as 1 minus the Simpson concentration or similarity index. Also, as stated in episode 1, we have the unbiased Simpson index, and that is represented as follows: 1 minus the sum of the frequencies times the frequencies minus 1 divided by capital N, which is the total number of individuals in the organization, times the total number of individuals in the organization minus 1. Again, that's represented as 1 minus the sum of the frequencies times the frequencies minus 1. Divide that by total number of individuals times the total number of individuals minus 1. That also can be written as 1 minus the unbiased Simpson concentration or similarity index. As I mentioned in episode 1, we have the biased Simpson standardized or evenness score. That is simply the biased Simpson score divided by the maximum score. So symbolically, that is 1 minus the sum of the frequency squared divided by the total number of individuals squared divided by k minus 1 divided by k. That also can be written as 1 minus the sum of the percentages squared divided by k minus 1 over k. That also may be represented as 1 minus the Simpson concentration score divided by the maximum score. There's also the unbiased Simpson evenness or standardized score that is represented as 1 minus the sum of the frequencies times the frequencies minus 1 divided by the total number of individuals times the total number of individuals minus 1. That is divided by the maximum score, which is represented as k minus 1 over k. The following may also be written as 1 minus the unbiased Simpson concentration or similarity score divided by the maximum score. This episode will cover the Kvalseth indices. They were created by Terrell Kvalseth in 1991. They are based on the probability of similarity. They are also based on the Simpson index. The Kvalseth indices have maximum and minimum values, which are different than the maximum values for the Simpson index. The indexes can be applied to qualitative data represented as frequencies or percentages, and it also produces standardized or evenness scores. The Kvalseth odds index can be written as 1 divided by the sum of the percentages squared minus 1. That also is represented as the sum of the percentages squared to the negative 1 power minus 1. The odds index produces an estimate of the likelihood or odds that two individuals selected at random from the population will have different ethnic characteristics. As I stated, the Kvalseth odds index is based on the Simpson index, and it's again 1 divided by the sum of the percentages squared minus 1. Recall that the Simpson concentration score is the sum of the probability or the percentages squared, and in this case it's 0.6106 or 0.611. So to calculate the Kvalseth odds for ethnicity is 1 divided by 0.611 minus 1, that equals 0.636, and that is interpreted as there's a 63% chance that two individuals chosen at random will have the same demographic characteristics, in this case that the individuals will have the same ethnic background. Again, as I mentioned a few seconds ago, the Kvalseth odds index has a maximum score and a minimum score. The maximum score is simply k minus 1, so it's the number of groups minus 1. To obtain the minimum value, you take the total number of individuals squared, divide that by k minus 1, again, which is going to be the number of groups minus 1, times the quantity of 2 times n minus k, so that's going to be 2 times the total number of individuals minus 5, the number of groups, minus 1. You divide the n squared, which is total number of individuals squared, by the denominator, k minus 1 times 2 times the total number of individuals minus k minus 1, and you take the inverse of that, or the reciprocal, so you divide 1 into that product. That gives you the minimum score. Or you can take the product of the numerator divided by the denominator to the negative 1 power, and that gives you the minimum score. To summarize the Kvalseth odds index, the maximum score is 4, and again that's k minus 1, so it's 5 minus 1 equals 4. The minimum score is 0.078 based on the complex formula for calculating the minimum score. The Kvalseth odds score is 0.638, which indicates that there's a 64% chance that individuals selected at random will have the same demographic characteristics, in this case will be of the same ethnic group. The Kvalseth index of homogeneity is represented as the sum of the percentages squared divided by 1 minus the sum of the percentages squared. In other words, that's the Simpson concentration or even index divided by the Simpson diversity index. And this index produces an estimate of the likelihood or odds that two individuals selected at random will have the same demographic characteristics, in this case that they will be of the same ethnic group. Now when the Kvalseth homogeneity index is applied to the Simpson index, or the data that we obtained from the Simpson index, that's going to be 0.611, again that is the concentration score, divided by the diversity score, which is 1 minus 0.611, that gives us a product or an index of 1.568, which indicates the odds that two individuals selected at random will have the same ethnic background. As I mentioned, there's a maximum score and a minimum score. In this case, the minimum score is 0.25. The maximum score is 12.887. And again, the homogeneity score is 1.568. Like the Kvalseth diversity index, the Kvalseth homogeneity index has a maximum score and a minimum score. The maximum score is calculated as capital N squared, so that is the total number of individuals squared, divided by k minus 1, which is 5 minus 1, times 2 times the total number of individuals in the organization, minus k, which is 5, minus 1. So it's going to be capital N squared divided by the denominator, which is k minus 1 times 2 times n minus k minus 1, or simply is 1 divided by the minimum score. Now the minimum score is going to be calculated as k minus 1 to the negative 1 power. In this case, there are 5 ethnic groups, so it's 5 minus 1 to the negative 1 power, or simply 1 divided by the maximum score. So to calculate the Kvalseth evenness score or standardized score, you take 1 divided by the sum of the percentages squared minus 1, so that's going to be 1 divided by the Simpson concentration score minus 1 divided by the maximum score, which is k minus 1. So in this case, the Kvalseth diversity score is 0.638. Divide that by 4. That gives us the evenness score, standardized score of 0.159. And again, like all evenness scores, that indicates that 60% of the maximum score diversity was obtained by the Kvalseth index. Like in the previous episodes, I compared the index scores. In this case, I'm going to compare the Kvalseth diversity and standardized scores to the biased and unbiased Simpson scores, to the McIntosh scores, the Holbert and Wilcox scores. As I mentioned in the previous slides, the Simpson diversity score is 0.638, and that is significantly higher than the biased and unbiased Simpson scores of 0.393. The Kvalseth index score, diversity score of 0.638 is also higher than the Holbert index score, H1, which is 0.393. The Kvalseth evenness score of 0.159 is significantly smaller when compared to the biased and unbiased Simpson scores of 0.487. It is significantly smaller than the McIntosh evenness score of 0.395. Again, it is smaller than those produced by the Holbert index. And lastly, it's also smaller than the 2.84 diversity score obtained by the Wilcox index. So in general, the Kvalseth index produces smaller evenness or standardized scores when compared to the Simpson, Wilcox, McIntosh, Holbert indices, and some of the other indices that will be discussed in the future episodes. So now that the Kvalseth indices have been presented, I'm going to apply the indices to the same gender by ethnic data that was covered in the previous episodes, as well as to the revenue data. I will cover both the standardized and the unstandardized indices. I'm going to apply the Kvalseth index to the gender, ethnic by gender data, as well as to the revenue data. And again, this is to be consistent with previous episodes. And I will also contrast or compare the index scores obtained by the Kvalseth index to those obtained by the Simpson index. So let me share with you the spreadsheet. So here I have the data for the gender, male, female, some other gender, unclassified, with the total workforce of 100 people. I have the frequency for each gender category. So there are 65 males, 25 females, 5 of some other gender, 5 unclassified. When I square those frequencies, I get a total of 4,900. I can get the percentage for each category. So for males, 65%, females, 25%. Some other gender is 5%, unclassified is 5%. So when I square those percentages, I get a sum of p squared of 0.490. Now remember I said that the Kvalseth index is based on the Simpson index. So here what I have is the Kvalseth homogeneity index. Remember, that is 1 divided by the Simpson concentration score minus 1. So here I have the link, which is 1 divided by P4, which is 0.490 minus 1. So that gives me the odds ratio of 1.041. Remember, I said that the Kvalseth index has a maximum value, and that is going to be K minus 1. So the maximum value is 4 minus 1, so that's 3 is maximum value. There's also a formula for obtaining the minimum score. And here's the complex formula. So it's 1 divided by the quantity of G4, which is going to be the total number of individuals times the total number of individuals. And that's going to be divided by 4 minus 1 times 2 times 100 minus 4 minus 1. Again, that is the inverse of the maximum value that's obtained for the homogeneity index. So that gives me a value of 0.059 as a minimum. So when I divide the odds ratio by the maximum, which is going to be 1.041 divided by 3, that gives me a Kvalseth standardized or evenness score of 0.347. And again, that is smaller than the Simpson standardized score of 0.680. Remember that the Simpson concentration score is the sum of the frequency squared divided by total number of individuals squared. So remember that the frequency squared is 4,900. And when I divide that by 100 times 100, it's going to be 1,000 or 10,000. That is going to be 0.490, which is the Simpson concentration score. To obtain the Simpson diversity score, is going to be 1 minus the concentration score. So it's 1 minus 0.490. That gives me 0.51. That 0.51 indicates that there's 51% chance that the individuals selected will be of different gender group. Again, if I want the standardized score, is going to be the 0.510 divided by 0.75. And recall that 0.75 is going to be K minus 1 divided by K. So it's 4 minus 1 is 3 divided by 4. That gives me 0.75. So when you get 0.51 divided by 0.75, that gives me the 0.680. And that is the percentage of the maximum diversity score that is obtained. So for this organization, it obtained 68% of the maximum value of 0.75 in respect to obtaining the maximum value of gender diversity. Again, that presents the Kvalseth index. So again, the standardized score is 0.347. That indicates that 34% of the maximum value of 4 was obtained. And again, as I said, generally, the Kvalseth index will produce scores that are smaller than those of the Simpson index, and I'm talking with respect to the standardized or evenness scores. Again, like in previous episodes, here is the data for ethnicity. So I have Asians, Blacks, Hispanics, whites, some other race. For the Asian workforce, I have 5. I have 20 individuals for the Black workforce, 15 individuals for the Hispanic workforce, 50 individuals for the white workforce, and 10 of some other race. Again, when I square the frequencies, I get a value of 3250. That's 3,250. And remember that I can use the power function in Excel, or I can just multiply the frequencies by themselves. So in this case, I just multiply 5 times 5 for the Asian group, 20 times 20 for the Black group, 15 times 15 for the Hispanic group, and so forth, all the way to some other race. I can also get the percentage and square the percentages. Again, that's going to give me 0.325. That's because I'm using the percentages. Again, the Kvalseth index is based on the Simpson index, on the Simpson concentration score. So to get the Simpson homogeneity index, it's going to be 1 divided by the Simpson concentration score minus 1. So it's going to be 1 divided by 0.325 minus 1. That gives me the odds ratio of 2.07. Again, there's the maximum value for the Kvalseth index. Again, it's going to be K minus 1, so it's 5 minus 1, it's 4. There's the long complex formula to obtain the minimum score. So when I apply the formula for the minimum score, I get a minimum score of 0.078. So when I divide the odds ratio of 0.277 by the maximum score of 4, I get the Kvalseth diversity index, the standardized score of 0.519. Again, that is smaller than the standardized Simpson diversity score for ethnicity of 0.844. Let me go quickly back to the Kvalseth index. So for the Kvalseth standardized score of 0.519, that indicates that 52% of the maximum value of 4 was obtained for for ethnicity. When I compare that to the Simpson standardized score, the Simpson standardized score is 0.844, which means 84% of the maximum value of 0.80 was obtained for ethnic diversity. So that's how you apply the Kvalseth index again to the ethnic diversity data that was presented in previous episodes. So here I have the Asian workforce, which consists of 5 individuals, and those 5 individuals are then segmented by gender. So of the 5 total Asian workforce, I have 3 that are male, 2 that are female, 0 under some other gender, 0 under unclassified. Again, I have a workforce of 20 Black individuals. They are distributed by gender. I have a Hispanic workforce of 15 individuals. Again, they are distributed across gender. The same for the white workforce of 50, and the same for some other race, which is composed of 10 individuals. Those 10 individuals, again, are distributed across gender. Here again, I multiply the frequencies. Rather than using the long, complex formula of the power function in Excel, I just multiplied each frequency by itself. So again, for the Asian workforce, it's 3 times 3 plus 2 times 2 for the females, times 0 for some other gender, and 0 times 0 for the unclassified. And I did that for each ethnic workforce by gender. That gave me the 1684. Again, remember that the Kvalseth homogeneity index is 1 divided by the Simpson concentration score minus 1. So here's the formula. So it's going to be 1 divided by the Simpson concentration score is 0.168. So 1 divided by 0.168 minus 1 gives me an odds ratio of 4.9. When I get the 0.49 divided by the maximum Kvalseth value of 19, that gives me a Kvalseth standardized score of 0.260, indicating that 26% of the maximum value of 19 was obtained. Recall that the maximum value is for the Kvalseth index is k minus 1, so it's 20 minus 1, so that's 19. Again, here's the long complex formula on how to obtain the minimum score of 0.340. Again, just for review, the Simpson index, the maximum value is obtained by k minus 1 divided by k, so it's 20 minus 1 divided by 20. That gives me a value of 0.95. Recall that the Simpson concentration score is the sum of the frequency score divided by total number of individuals squared. So it's going to give me the 0.168. The Simpson diversity score is 1 minus the concentration score, so it's going to be 1 minus 0.168. That gives me the 0.832. Again, that is the probability that an individual selected will differ from another individual with respect to race and ethnicity and gender. I have the standardized score, which is 0.832 divided by the 0.95. That gives me a standardized score of 0.875, which means that for this organization, it obtained 87% with a maximum value of 0.95 with respect to ethnicity and gender combined. Again, here I have the contingency table for ethnicity and gender. I have the frequency squared. Again, I have the Simpson index values for the maximum. I have the Simpson concentration score, I have the Simpson diversity score, and I have the Simpson standardized score for ethnicity. Again, remember that the Kvalseth maximum score is k minus 1, so it's 5 minus 1, so that's the maximum score is 4. And again, this is, I'm looking at it in terms of the ethnic group for male, the ethnic group by gender, so the first row is for males. So I'm looking at the diversity of the male group. Again, here's the formula for obtaining the Kvalseth minimum value. Again, to obtain the Kvalseth homogeneity score, it's going to be 1 divided by the Simpson concentration score minus 1. So that's 1 divided by 0.345. That gives me a value of 1.896. Again, that's 1.896. When I divide that by the maximum value, that gives me a 0.474, which means that for ethnicity by male group, I obtained 47% of the maximum value of 4. By comparison, I obtained 82% of the maximum value of 80 when I use the Simpson index. Again, as stated, the Kvalseth index, the standardized score would generally be smaller. And then what I did for the other gender groups, I just copied the formulas down. Now let's go briefly to the Asian group by gender. So here I have 4 groups for gender. So if I use the Kvalseth formulas, remember the Kvalseth maximum value is going to be the number of groups the number of groups minus 1, so it's 4 minus 1 gives me the 3 for the maximum value. Recall that the Kvalseth homogeneity index is based on the Simpson concentration score. So here I have 1 divided by the concentration source for Asians for gender, which is 0.520. So it's 1 divided by 0.520 minus 1. That gives me a value of 0.92. When I divide the 0.92 by 3, that gives me a standardized Kvalseth index of 0.308, which means that 31% of the maximum value of 3 was obtained for the Asian groups for gender. Again, I have the Simpson maximum score, the Simpson diversity score, the Simpson concentration score, the Simpson evenness or standardized score of 0.640. What I did, I just copied those formulas over to make it easy for myself. Just copied them over. I did the same thing for the department. I also looked at gender by ethnicity. So rather than looking at the rows, I looked at the consistency table. Again, there are 20 groups. To get the maximum value for the Kvalseth, it's going to be 20 minus 1, so that's 19. So 19 is the maximum value for the Kvalseth homogeneity index. I have the formula for the minimum value. Recall that the Kvalseth homogeneity index is going to be 1 divided by the Simpson concentration score minus 1. So here I have 1 divided by 0.168 minus 1. Again, that gives me an odds ratio of 4.938. When I divide the 4.938 by 19, that gives me a value of 2.60. Again, compare that to the Simpson standardized score of 0.875. The Simpson index generates a higher standardized score. Again, briefly, the Kvalseth standardized score of 0.260 indicates that 26% of the maximum value of 19 was obtained with respect to gender by ethnicity. By contrast, the Simpson index generated a standardized score of 0.875, indicating that 87% or 86% of the maximum value of 0.950 was obtained. So here I have the revenue data for XYZ nonprofit. Recall that the corporate revenue was 80,000, individual revenue was 250,000, fundraising was 45,000, investments was 10,000, grants represented $18,000 in revenue, for a total of 103,000. Corporate donations represent 20% of the total revenue. Individual contributions represent 62%. Fundraising represents 11%. Investments is 2%. And the grant revenue represents 4%. The R-squared value, that is each revenue source times itself. So that's going to be 80,000 times 80,000 plus 250,000 times 250,000 plus 45,000 times 45,000 plus 10,000 times 10,000 plus 18,000 times 18,000. That gives me the R-squared value. I can also obtain the percentage squared by multiplying each percent by itself. Shrink that down so that when I do that, and then again, I can use the power function here. I just multiplied the percentage by itself. That gives me a value of 0.439. So that is the Simpson concentration score. Again, the Kvalseth index is based on the Simpson index. So to obtain the Kvalseth odds homogeneity value is going to be 1 divided by the concentration score of 0.439 minus 1. So that gives me a value of 1.276. Recall that the maximum value is K minus 1. So the maximum value for the Kvalseth homogeneity index is 4. And the minimum value is obtained with this complex formula. Here the value is, the numbers are extremely huge, so I get a minimum value of 0. So to obtain the Kvalseth evenness or standardized score is going to be the 1.276 divided by 4. That gives me a value of 0.319. And again, that 0.319 indicates that 32% of the maximum value of 4 was obtained. And in comparison to the Simpson index, standardized index, the Simpson standardized index is 0.701. And again, I get that by first obtaining the Simpson standardized score, the Simpson index of concentration. In this case, I use the frequencies, so it's going to be the percent of the frequencies of each revenue source divided by total revenue times total revenue, so that's n squared. When I do that, that gives me a concentration score of 0.439. To obtain the Simpson diversity score, recall from episode 1, it's 1 minus the Simpson concentration score, which is going to be 1 minus 0.439. That gives me the Simpson diversity score of 0.561, indicating that there's a 56% chance that if I select two sources of revenue, they're going to differ. The Simpson evenness or standardized score is going to be the Simpson diversity score, 0.561 divided by the maximum score, 0.80. And recall that the 0.80 is obtained by the number of groups minus 1 divided by the number of groups. So it's going to be 5 minus 1, which is 4. 4 divided by 5 gives me 0.80. So again, to obtain the Simpson concentration score, the Simpson evenness score is going to be 0.561 divided by 0.80. That gives me the 0.701, indicating that 70% of the maximum value of 0.80 was obtained for revenue diversity. Again, I did the simulation, the revenue simulation. So I increased corporate donations to 95,000 from 80,000. Gives me a percent of 20%. I kept individual donations stable, constant, so it's 250,000 under the revenue scenario. Because I increased all the other revenue, the individual contributions now account for 53%. Again, I increased fundraising to 65,000 from 45,000. So under the revenue scenario, I have fundraising now represents 14%. Again, I increased investment revenue to 25,000 from 10,000. I increased the grant revenue to 35,000 from 18,000. Again, I squared the frequencies for each revenue source. Also squared the percentage. For the maximum value for the Kvalseth index, that stays the same because there's 25 revenue sources. The minimum value stays the same. That's because the numbers are large in terms of revenue. Again, recall that the Kvalseth homogeneity index is based on the Simpson index. Again, so to get the Kvalseth homogeneity index is 1 divided by 0.351 minus 1. So that gives me the odds ratio of 1.847. To obtain the Kvalseth standardized or evenness score is going to be 1.847 divided by 4. That gives me 0.462. So if I interpret that, that's that under the new revenue scenario, should I obtain the revenue that's forecasted, that's going to then represent 46% of the maximum value of 4. Again, I did the same thing using the Simpson index. So the standardized score is 0.811, indicating that should I obtain the revenue that is forecasted, I will obtain 81% of the maximum value of 0.80. Now, these percentages at the bottom indicate the percent increase that I should expect if the revenue scenario comes to fruition. It also indicates that the Kvalseth index seems to be more robust in detecting differences when compared to the Simpson index. So the percent increase for the Kvalseth index is 0.45 or 45%. The rate of change for the Simpson index is 16%. And again, indicating that the Kvalseth index appears to be more robust in detecting subtle differences in comparison to the Simpson index. Again, the Simpson index only increased by 16%. So in terms of the robustness of the indices, I would suggest using the Kvalseth index, but remember that the Kvalseth index produces standardized scores that are significantly smaller than the Simpson diversity scores. If you would like to obtain a greater understanding of the indices I will cover in previous episodes, there are several books that you can purchase through Amazon or through the publisher Cambridge Scholars Publishing in the UK. One book is Assessing Organizational Diversity with the HEAP Index, and this book covers the HEAP Index, which will be covered in a future episode, the Hill Index, the Holbert Logarithm-Based Index, also covers the Shannon Index and the Sheldon Index. You can also purchase Assessing Organizational Diversity with the Smith and Wilson Indices, which cover the Simpson Index, the Smith and Wilson Indices. Another book that you can purchase is Assessing Organizational Diversity with the McIntosh Index, which covers the McIntosh Index extensively. If you would like to know about the Index of Qualitative Variation, which will not be covered in this YouTube channel, you can purchase the book Assessing Organizational Diversity with the Index of Qualitative Variation through Amazon or through the publisher in the UK, Cambridge Scholars Publishing. The reason why I'm not covering the Index of Qualitative Variation in this channel is that it is cumbersome to use, it's inefficient. It also produces scores that exceed the maximum value due to rounding errors. However, I published a book to illustrate how to apply it to demographic data provided by organizations. Another book that you can purchase is Assessing the Validity of Diversity Indices. And this book examines the indices and how they are related to each other statistically. If you want to know how to use quantile regression, quantile regression is applied to the indices that have been covered in previous episodes. It also applies quantile regression to the Shannon Index, which will be covered in a future episode, as well as to the other logarithm-based indices that will be covered in future episodes. So these are 6 books that you can purchase at Amazon or through the publisher Cambridge Scholars Publishing in the UK. Book 9 in the series should be published in September. There was a delay in getting the typeset file. So once I get the typeset file, I'll write the index to it and then send it to the publisher so it can be in print. So it seems that it will be available in the 2nd or 3rd week of September. Briefly, next week's episode 7, will cover the Keefe-Bruggeson Index. Like the indices that are presented in previous episodes and in this episode, the Keefe-Bruggeson Index is based on the Simpson Index. It utilizes the Simpson concentration score, which is represented as a sum of p squared. And recall, in this episode and in previous episode, capital N equals the total number of persons in the organization. P represents the percentage of individuals in each category or group. Consistent with this episode and those of the previous episodes, the index will be applied to the gender data, ethnic data, gender by ethnicity data that have been used throughout the episode so far. And the Keefe-Bruggeson Index will also be applied to the revenue data that's been illustrated in this episode and in previous episodes. So thank you, and I'll see you next week.